Cloud. Good evening, everyone. Today is Monday, August 17th, 2020, and this is the Monday night Tangerine SDR Zoom or Tapper. My name is Nathaniel Frizzell, Whiskey 2 November Alpha Foxtrot, and I am filling in for Dave KV0S, who is not with us this week. So let's see. So we'll start off just by our normal round of introductions and updates. So things for me, the summer vacation in quotes, has come to a close, and I've started teaching today. I have an introductory astrophysics class and digital signal processing class, and we actually had on-campus classes for the first time today, socially distanced with masks and everything. So hopefully that will continue along smoothly, but we shall see. Anyway, so far so good. So we'll turn it over now. I'll try to follow this list, and we'll go over to Dan and November 4 X-Ray Whiskey Echo. Go ahead.
Thank you, Nathaniel, and hello, everyone. Can you hear me okay?
Yes, just fine.
Okay, perfect. I changed my audio settings, after having difficulty the last couple of weeks, and I think I got it sorted out. Anyway, didn't really do a lot this week. I did some reading, and I wanted to relate a little bit of that to the group. And I'll start out by telling a little story. I have a 29-year-old daughter who at one time wanted to be an astrophysicist. She became a lawyer instead, but that's a whole different story. Some years ago, we were talking about television programming, and I told her, I said, well, there aren't too many programs that I like that I think are worth watching. I don't watch much television. She suggested that I watch what at the time was a new program called The Big Bang Theory. She thought it was hilarious, and it fit my slightly geeky interest set perfectly. So I don't know if you recall, but early on, the tone of the Big Bang Theory was a little darker than the later episodes and a little bit more character development. Anyway, I kind of reluctantly tuned in, and while watching the show the first time, it struck me that I'd gone to school with or worked with people just like the characters on the show over the years, and that began my interest in the lives of 20th century physicists. And the first name on the list that I put into the search engine was a guy named William Alfred Fowler, who won a Nobel Prize in 1983. As a 4, 5, and 6-year-old, we lived a couple of blocks down the street from where he lived as a child, actually through early adulthood, in Lima, Ohio. And I walked by his house every day on my way to kindergarten. It was right down the street from the school, and I lived just a little bit further down the street. So anyway, that was kind of the first one I read, and then I went on from that to read a few more. And then I came across a guy named Joe Taylor, who we all know from FT8 land. And Joe was just starting out in astrophysics in the 1960s. I'm not sure when he graduated, but I think he got his PhD maybe in 67 or 68, something like that. And that kind of piqued my interest. And then Joe Taylor came along later as the originator of FT8 and Whisper and a few other weak signal modes. Also, he worked with the same people that William Fowler worked with. The Burbages were a couple of the names that were mentioned. It was a husband and wife team who did the paper with Fowler that won the Nobel Prize. As most, I think, Nobel Prizes in physics or sciences are shared between people. So anyway, I wanted to mention that because if you're interested, the American Institute of Physics has a pretty good archive of oral histories of people who were early physicists. They give you a really good insight into what we're trying to do today, believe it or not, because a lot of them did the same things back in the 60s, especially with radio astronomy. So anyway, I've talked long enough. Back to you, Nathaniel.
Thank you very much, Dan. That's very good. All right. Next, let's go on to Alex Mule. Go ahead.
Hi, I'm new here. Professor McGaw invited me to join in on this. I had sort of an interest in SDR before I came here. I have no clue. I'm an incoming grad student, and I really have no clue what my plans are and who I'm going to do research with or whatever. But SDR is cool, so I appreciate you guys letting me sit in on this meeting.
Oh, you're welcome. Well, thank you for joining us this evening. Good to have you, Alex. Bill, AB4EJ, go ahead.
Thanks, Nathaniel. Good evening to you and good evening to the group. I've been very busy working on the software, setting things up to be able to manage multiple channels. So right now, the way I'm going to set it up is channel 0 will be the spectrum data, which then goes into, it can go into ring buffer, what we call snapshot mode, or fire hose. And I've figured out how with clever multiprocessing, I think I may be able to run all those modes at once. Channel 1 will be FT8 and channel 2 will be Whisper. And with a sufficiently powerful processor, I think it might be possible to run all those simultaneously. So I'm going to be genning up some tests this week. I have been able to run a simulation of 6 8 kilosample channels at the same time as 2 FT8 channels, which are 4 kilosample channels. I've been able to get that to run, and I'm hoping to be able to expand that a little bit. But right now, one little handicap is the device that I'm using as a stand-in for the data engine is a Flex 6600, which can only output 4 channels at once. So I can't really simulate as much as I would like to on that. But anyway, I need to talk with Scotty when we get to our discussion, because I have discovered, we have talked about how the data engine is going to ACK or NAC things. And once upon a time, I remember Scotty telling me that he was not planning to ACK a start data collection command, but I think I really need to have that, because it really makes a terrible mess of things if you can't depend on getting an ACK or NAC back from a command, because you got to have that in order to know that the data engine is there and it's responding, rather than having to look under the port and wait so many milliseconds and do all this and that. So anyway, we can go into that a little bit more. I do have a very nicely laid out set of thread designs for how a data engine should work, and I will document that and pass that along in case the team that's going to do the FPGA programming would like to have that as an idea starter. So anyway, back to Ned.
Thank you very much, Bill. That sounds very good. Sounds like a lot of good progress this week. Why don't we go over to Scotty in the radio room, WA2 DFI.
Okay. Can you hear me okay?
Yes.
Okay, well, quick to answer Bill's question, yes, all commands should be ACT, just the streams that are not ACT. So, yeah, I agree with you. Everything that's control or setting up streams, all that they should all be ACT. And the question I have for you, when you mentioned you may be running out of horsepower for decoding all 4 streams, I'm hoping that in our protocol it's possible to direct each stream to a different IP address, so you could theoretically have multiple single board computers doing your decoding for you, or a big powerful computer if you have some heavy task that needs to be done. But anyway, we can talk about that when we get further down the log here. This week's been mostly working on the data engine. I've got the bank assignments pretty well done. I've run into one little problem I just have to solve first. And I had a conversation with John Ackerman today on the clock module. So we've kind of got the clock module sort of sketched out, and need some help from Tom that maybe we can talk during the aftermath here. And But again, zeroing in on getting this thing done, I really want to get the data engine in layout so that we can start producing RF modules and data engines and start doing some hardware debug. So back over to you, Nathaniel.
Thank you very much, Scotty. That sounds very good. Let's go over to Gary, AF8A.
Yeah, good evening, everyone. Just sitting here checking in, reading the mail, trying to keep up with all the goings on. So when the PSWS becomes a reality, I'm well grounded in how we got there. That's it. Thank you.
Thank you, Gary. Sounds good. Tom McDermott, N5EG.
Oh, good evening to everybody. It's been another quiet week, and Scotty, we can talk about things. I'm trying to borrow a high-performance signal generator to do some receiver tests, and I'll need to try to estimate when that might be. So probably something else we can chat about later on. Back to the group.
Thank you very much, Tom. Sounds good. David Holman, go ahead.
Well, I can't say that I've been overly active like I'd like to be. This is my second Zoom meeting. I'm still trying to catch up. What FPGA are we using for the data engine? And maybe when I get some more time, I can help out with that a little bit.
Scotty, do you want to answer that really quickly?
Yeah, we're using a Max 10, Intel Max 10, Intel/Altera. The biggest Max 10 is a 10M50 in a 672-pin package, and the fastest speed grade, the i6 industrial temp. So if that helps any. Are you an experienced Intel or a Xilinx guy?
I've been more Xilinx than anything else. So Intel is somewhat new to me. I know they make the processors that go in the Windows machines, and Windows and I aren't big friends either. So we have our disagreements on occasion, but we can go there. I've been occupying my time looking for another job because my contract got suddenly defunded. So
I'm sorry to hear that.
As much as I would like to do here, but I'm hoping that will change.
Well, FPGA designers are always welcome. In fact, everyone's always welcome, but we always have the shortage of FPGA designers. So
one probably should explain that it's actually Altera.
yeah, it's the Altera that Intel bought. So it's an Altera design originally, and I guess Intel bought them in 2016. So it's been about 4 years now.
Yeah. All right. Very good for now. Why don't we go to Dave Witten, KD0EAG.
Well, I haven't done a lot that's exciting myself. I've been corresponding a lot with Jules Maddie, and he's been doing lots of interesting testing, and is very pleased with some of the results he's gotten. He has especially, as I understand it, had some good results by using some very, very low dropout, very low dropout voltage regulator that apparently gives him more freedom with the overhead on the magnetometer extension. But for myself, I've mostly been trying to make some boards for testing and some things for my own purposes, and been kind of consumed by other things that have been taking up lots of time. So that's it from me. Back to Nat.
Thank you very much, Dave. And as always, I very much appreciate the work that you're doing and that Jules is doing, and everyone else working on the magnetometer. Let's see. How about Hyomin? Why don't you go next?
Hey, good evening, guys. Hyomin. Yeah, there's nothing to really report tonight. I'm still working closely with Dave Witten and especially this time, I'm also working with our engineers at NGIT to figure out how to verify the magnetometer that we have right now. So I think we have good way to do it. We have Partington magnetometer around, so that's so that we can compare signals coming from two magnetometers to verify that the magnetometer that we have is behaving correctly. But otherwise, I'm making really slow progress these days. But still working on it. We'll make it through. So that's all I have.
Thank you very much, Yeoman. That sounds great. Dave McGaw, N1HAC.
Hey there, and welcome, Alexander. I'm glad you were able to make it over. I've been trying to get the magnetometer running, and not having much luck with the extended version. Maybe we can have some discussion about that, but the standalone version works fine, but I'm not getting anything out of the extender. It's all assembled, power seems to be right, but doesn't seem to be tweaking the I2C, so software is not seeing anything. I have to debug that. Even putting a scope on it, I couldn't figure out yet what's going on there. The other thing, though, that's been going on this week is I've been watching the E-Loran test, which I'm interested in. That's 100 kilohertz pulsed navigation and timing signals that coming out of New Jersey right now. And as we have observed, they used to be megawatt transmitters, and the one I used for frequency reference was out of Nantucket, and I could get like hundreds of millivolts off of an antenna if I resonated it. Whereas 75 kilowatts coming out of New Jersey is a little bit different in signal strength. So I had to make up a good VLF, VLF-LF loop antenna and a preamp so that I could get enough signal to lock my Loran timing receiver to it. But that's been successful. It's been fun to watch. I keep hoping they bring that back as our backup because it's a very robust timing system and could be used for our timing if it comes back when if GPS is not available or desirable. It's plenty accurate enough, can even give you the time of day with the E-Loran system. So back to net.
Thank you very much, David. Very good. All right. Next, we have Dev. And Dev, you have a new call sign, right? Dev, are you there? Maybe we'll come back to Dev.
Hello?
There he is.
Hey, Dev, how are you?
Yes. Sorry, I was speaking without unmuting. So good evening, everyone. I got a new call sign, which is KC3PVE. So that's the success on my part. And with that call sign, I'm continuing to work on my project. We have some minor success on there too. Otherwise, it's a regular, fine, slow business, I would say. Thank you.
Thank you very much, Dave, and congratulations on your new call sign. And next we have Jonathan Rizzo, who is now a general, KC3EEY.
Hi, everybody. Yes, I upgraded to my general last week. Class started for me as well. I'm actually one of Nathaniel's students. I'm in his digital signal processing class, and I am interested to hear of the hardware updates that everybody was talking about. Back to net.
Thank you very much, Jonathan. And next, how about Mike, AA8K?
Greetings to everyone on the conference. Back to you, Nathaniel.
Thank you, Mike. I think last but not least, Jay, Whiskey Bravo 8, Sierra Bravo India. Go ahead.
Good evening, everybody on the net. My video microphone is not working tonight, so you'll just have to put up with my wonderful voice. The bad news is my IC756 Pro looks like it's QRT, and it's no longer supported by ICOM. Bummer. Changing the subject back to software, I am a software engineer in the automotive industry, did that my entire career. And one of the things I noticed in one of the email blasts that came out was doing code reviews, and that got me to thinking. When you guys developed the code, have you known or anything about something called the MISRA, the Motor Industry Software Reliability Association, the MISRA standard? Is anyone other than me familiar with that document? It's how to do C code in embedded systems.
Yeah, I think there was some discussion on the listserv about that. I only know about it from you. Bill, did you want to say anything about that?
I put all my comments into the listserv.
Yeah. So I think there's been some. If we want to talk about this some more, we can talk about that during the discussion tonight.
Yeah, yes, let's do that.
Okay, great. And I think we have one more person who just joined us, and that is Dan Twett. Go ahead. So Daniel, if you're there, what we do is.
Yeah, hi.
Hi.
KK6 VDR here,
How are
Thousand
you?
Oaks, California. A ham running for city council here in Ventura County also. So for what's that's worth, just tell your ham friends.
Sounds great. So yeah, people just introduce themselves and say what they've been up to this week, and then we're gonna go into general discussion.
Yeah, I'm probably the most futurist candidate. Big fan of like transhumanism and Bucky Fuller and life expansion. So all kinds of topics you don't hear from candidates. Regenerative design, genuine progress. So yeah, working on introducing myself to the community with no money. I'm kind of running a keeping the money out of politics kind of campaign. But yeah, extra class DM04NE is my grid square, and want to get into off-grid internet and other things, and do a lot of citizen science with the tech maker community.
Great. Well, thank you very much for joining us.
Thanks.
All right. Well, I think that's it for the list today. So why don't I turn it over to Scotty, and you can start the discussion. Scotty and Tom, you can start the discussion on hardware updates.
Okay. I guess the clock module, is that where we should start, Nathaniel? Or that's where I know.
Have the magnetometer prototypes been sent out?
What for you mean the hat ones? No, we have not. We have not completed those yet. In fact, I'm still waiting. I need to talk to Nathaniel after the meeting here, but I'm still waiting to fire that off. And it sounds like it's a good idea because apparently Jules has come up with the idea of lowering the regulator output to 3 volts, which still runs everything and gives us more overhead. So don't know why I didn't think of that, but can't think of everything. So I think we'll use that regulator if you're in agreement, and substitute that for the.
It's got a very much smaller footprint, at least the one that he was actually physically using.
Oh, so it's not the same footprint as the one?
I don't know. There may be one available that is, but the one he sent a picture out on the he managed to make it work on there, but it's I don't believe it's the same if I saw it correctly.
Just SOT 23 instead of a The one with the tab?
Uh,
I
I
missed the picture for some reason on the.
It's a little thing, but I you just have to double check it.
Okay.
I
Well,
expect we'll be able to find an LDO with the current package as well, either
Well,
3 or 3.3.
The LDO that we've got is a very nice, is very low dropout, but the trick was going down to 3 volts, which gives you still regulated output, and both parts still run on 3 volts, so it just gives you another 0.3 of a volt of drop allowed in the cable, and still maintain a regulated output. So that's
Right.
a good call.
Well, I was going to suggest that we might break away the 5-volt feed to the magnetometer cable so that we could actually run it at higher voltage as well.
Well, there is a separate power input on the magnetometer, separate connector on the Raspberry Pi version that will allow you to run it. Although you're right, it doesn't break it loose from the Pi hat if you plug it in. So if you wanted to do that on the local end, you'd have to not plug it into the Raspberry Pi, and you have to run a cable over for the I2C. Right.
Well, I'm thinking on the Raspberry Pi end, but the problem is that the 5 volts is tied to the I2C repeater as well. So it might be nice to be able to break that connection away and run just the cable off of an independent supply.
Oh, I see. Yeah, because the I2C repeater runs on 3 volts, does it not?
Yeah,
No,
but it's regulated
it runs
down.
off at 5 volts.
It's regulated down from the 5 volts.
Right. So
Yeah, and I was just reading its data sheet, and I believe it's the cable side that's run from 5 volts, and then the other side can be anything widely variable.
Yeah, it has 2 supply inputs.
Right, and I'm looking now. That's what I thought. No, you're right. The cable side does run 5 volts. You're right. Okay. And then, which means that the cable on the pardon me, the power in on the other side would come in off the cable, and it would be somewhat less than 5 volts because of the drop in the cable. In fact, it could be significantly less, I guess. Yeah, I don't have any way to connect that down there unless you want to solder a wire onto it. So.
Yeah, well, another connector of some sort. Just putting that out there. Yeah, the data sheet says it'll run from lower, but it likes to be 5 volts.
Yeah.
How much more reliable would this system be, or how much farther could the cable run be if you had the 5 volts instead of the 3 volts?
Well, I think we're really limited by the capacitance of the cable.
Yeah.
And I guess
well, it's actually not the capacitance because it's using it as a transmission line. It's more the line loss and delay times.
Well, then you'd have to lower the baud rate, lower the data rate, and then the delay times wouldn't be important, or they would have to be made unimportant.
Well, I believe that Jules has been operating this out as far as 400 feet.
Yeah, I noticed he said 400 feet on his email.
Yeah,
that's pretty good.
Yeah, as long as you have the voltage to run it at the far end.
Yeah. So, I'm really interested to hear the results of the comparison test that he is running, because, and that Yeoman is going to verify at Jenny Jump, because that's really going to decide for us whether we're going to be able to do these, when this part's going to work, right? I mean,
well, his results so far look very good. How they compare with Jenny Jump is kind of an open question at the moment, and why there's a discrepancy there. But they do seem to compare amongst themselves multiples of these, and with the results from that he's using from the Fredericksburg magnetometer site. Yeah, at least in his way of looking at it. Whether this is correct for our needs, I can't say. That's out of my. But he's certainly been active.
Yeah, I was trying to interpret these graphs. Maybe you can help, Dave. This is seconds on the x-axis, right, across the bottom?
I believe so.
And then the magnetic reading is on the y-axis.
Uh-huh. Yeah, X. Yeah, it looks like it. Kind of moving around too quick for me, but yeah.
I'll just leave it there for a minute.
I saw all those numbers running together. I'm wondering what in the heck did I see that it's two rows interleaved, and if you look, it's seconds. I think is correct.
Right.
Huh. And then this is in nanoteslas?
I believe so.
Looks like it. Do you know that this is raw data directly coming from the system or somehow averaged? Because the data that I showed you from JennyJump were some minutes of running average. Otherwise, it was so jittery. I had to take some average. I wonder if this is average one or just raw data.
Well, it would be good to ask him that directly, but I believe he was for a while working with your mechanism for averaging and comparing them.
This looks really. Sorry, go ahead.
But this may be
on the slide. It says it was an average of 10.
Yeah, there it is.
Oh, okay.
But he's using a cycle count of 600 instead of 400.
Do you know where this is located? How far is it from?
He's said that several times. I have to look. He's not. I believe he's in New York.
He has 47.7 east longitude and 235 degrees at cutoff. So that's probably.
That's cold latitude, right? So that's. Right?
So co-latitude.
That's got to be latitude 47 degrees and then longitude 253.
Well, co-latitude means 90 minus. That gives you your latitude.
Oh, okay.
Why is it
it's but either way, like 47 is very close to what do you call it?
Yeah, it's close to New York or.
He's in New Jersey, isn't he?
No, he's in New York. He's in upstate, out of the city, but not way out there. He's maybe a little north.
Do you remember his call sign?
His call sign?
Geomagnetically, I think New York, wherever that is, Virginia, they're pretty close.
I think his call sign may be at the end of this document.
Yeah,
K2. He doesn't usually put it there, but K2,
But
GJ.
what's really encouraging is that if you scroll up, you compare x-axis.
Yeah, I think
even the small dips like W shape and top of around 18,300, like W shaped dip, two dips.
He's in Hillsdale, New York. Which
that one.
Yeah. So here's his.
So
Hillsdale, New York.
He's actually about halfway between Albany and New York City.
And it is co-latitude because the latitude here is 42.7, and if you do 90 minus 47.7, you get 42.2. So yeah, he did write co-latitude correctly.
So okay, I mean that's pretty far geographically, but I think geomagnetically it is not significantly high. not significantly distant. And what's
Right.
really encouraging is that if you look at the x-axis value, right,
To
Yeah, it's gonna be
okay,
about
so
400 miles, Nathaniel. Not a bad guess, huh?
yeah, I mean, this is,
He's
I'm
he's
talking
he's
about,
almost the same latitude or same longitude as Jenny Jump, just higher latitude. So
yeah, but this is sort of mid-latitude geomagnetically. So geographic distance might be a little bit far away, but geomagnetically,
it's
it is quite
close.
close.
yeah,
If you show me the graph, x-axis, near the top of the trace over there, yeah, the small dip, you can see the dip over there, and there's another one, there's a kind of W shape there. The other around like 18, yeah, that W shape, yeah. So even and the at the at the data, that's the bipolar structure. That one, yes. Very similar. So this is super encouraging that we are actually measuring actual geomagnetic field. So the resolving power of our magnetometer is very comparable. So I think this is super encouraging.
Yeah, this is good.
I can say that he's very precise about everything he's doing.
Okay.
I may not always be able to articulate it back to you all as
Hey,
much,
Dave,
but he's
have you read his biography?
parts of it. Yeah,
It's easy, isn't it?
yeah, he knows what he's doing.
Yeah.
So I like to say that, you know, we should not be discouraged by what we saw from JNIJump data, because maybe something could go, something, you know, was done improperly maybe. So, you know, I'm going to make sure that our magnetometer at JNIJump is working properly. But this, by looking at this data, things are looking really, really promising.
That's good. And he sent us another. This is the same data, I guess. But
Yeah, it looks the same.
yeah, so it's just not compared.
I don't
What is
understand that graph though.
what is this top one? Yeah, what's the top one here?
My guess is that's a temperature on the
Yes.
module, which is buried in the
That's
ground.
that's been the big question he's been trying to answer, as well as, you know, come up with comparable results.
And it's scaled to the top diagram too. If you look at the seconds,
Yeah.
Yeah.
the x-axes are the same.
Yeah.
Yeah. So I think, you know, he's got the magnetometer buried in the ground, so you expect minimal and slow temperature changes. And so I'm going to guess that that's temperature in Celsius.
Yeah.
Yeah. He sent me a separate email that I don't think was forwarded to the list, where he, you know, quite excitedly says, you know, I'm just blown away by how good this seems to be. So he at least is happy with what he's getting, and it looks impressive to me.
That is very good news.
Yeah.
So I guess one of the things that we've been talking about on the emails with Dave and Hyomin is giving an update on this at the Tapper DCC. And I know, Dave, you're going to be tied up probably for a while.
I'll know tomorrow.
Okay. So maybe what I should tell Steve Bible is just hold a slot for us, and then we can still decide who's actually going to write and or give the talk, and we can just have him hold the slot for us. Does that sound appropriate?
Sounds good to me.
Sounds good.
Okay. And then,
And
yeah, and
also-
then you can figure out who's the most appropriate person to give or write the talk, or maybe you want to work together on it. And, Dave, if you feel like it's too much for you, maybe Hyomin can work with Jules and come up with something. But,
Yes.
Yeah,
I'm pretty sure I'll be able to give kind of an outline of at least some points before the end of the week. But
yeah,
because I know Steve Bible has been assigning half-hour slots to pretty much all the presentations
yeah.
because he doesn't feel that a 15-minute slot's really enough to present and then take questions.
Mhm.
So if you don't feel that a half hour is doable because it's kind of long, then maybe you could, if you get a tag team like Tom and John and I are going to do for the hardware, and fill 30 minutes with some on your experiences and some on Jules' observations and some on Hillman's observations, that kind of thing. That would work great.
Yeah.
You could do it.
Yeah, we could put you all down as co-authors, and then you can share the slot.
Mhm.
Or if you really don't want to do that, then I'm sure Steve would accommodate you a 15-minute slot if you wanted.
Mhm. Yeah, I think whatever you're comfortable with.
This looks excellent, though. I mean,
Yeah.
Well, Jules has been making quite a few graphs and things that would be useful, I'm sure. And I suspect Yeoman has or will have something interesting to say along that. And I'm kind of being a spectator right now.
have you been able to run this at your place?
No.
So is it supposed to be identical to what I have?
No, not absolutely. He keeps playing with the hardware. He's got a couple of different setups. He actually did this last stuff with both of them and got them to match. But it's similar. I have not been able to. Well, I have had some difficulty with these boards myself. I don't know why. And frankly, David McGaw, I understand.
So it's possible that what he has and what I have could be maybe slightly different in terms of operation.
I seriously doubt it.
The magnetometer piece is the same, right?
Yeah, it's really just the glue, and which is what this board's mostly about, and where I've had difficulties. And they were going along very well up to and through the one I sent to you. But I've been trying to make ones for myself, and I've had difficulty. So I've even designed another board, gone a couple of iterations for, but anyway, not to belabor that, it's these are terribly equivalent, and the thing that that Jules is doing is pushing the limits of the hardware to try and find, what is the manufacturer telling the truth? Is what's the reality here? Pushing the envelope where he can, and also seeing how it compares in the fine details between between what he's seeing and what we've made. But there's I don't know where to go with that. I've been fighting with this thing on my end for a while. but I think, Hillman, that they are equivalent. Much more significant differences are things like experimenting with the cycle count and other, parameters that he can manipulate using the hardware that we have.
I remember he mentioned that cycle count can affect resolution. Right?
Yes, we've always known that from before we built anything.
Part of the reason, maybe? I don't know.
Well, yes. Actually, the earliest discussions, including Tom and I believe Scotty, we always discussed running this at non-default particularly the cycle count. The defaults are really not meant for our kinds of uses, I don't think. And so he's really been doing the work that's been needed to be done to see where the optimums might be. And he understands. I wish he'd come on here because he could explain it better than I can. But we've always planned to go higher with the cycle count. There are improvements in the behavior, but there's also diminishing returns beyond a certain point. I think 600 may be as far as we can go. And then these other issues about voltage and making sure we don't, that we have reliability over at least the specified distance, preferably a good bit more. And temperature sensitivity.
Okay, good. Thanks.
By the way, just to sanity check on these latitude, longitude, that east longitude is not New York. That, if you translate it to west longitude, is 106, not 73, and is near Casper, Wyoming.
So that would be 106 degrees west?
Yes.
Well, that doesn't sound right because we're 112 west and we're in Arizona.
Well, I just put in for 42.3 north, which is the latitude for that co-latitude, and minus 106.7, which is 360 minus.
Yeah. Well, if you look on his QRZ page, he put in his latitude as long as minus.
Doesn't mean that that's where he is.
Well, yeah.
No, his latitude on QRZ matches the co-latitude here.
Well, maybe he made
I didn't pay attention.
Numerical error there.
Yeah.
Either that or he's out in Casper, Wyoming.
No, I'm certain he's not. He's in New York. Because I've mailed him things.
Yeah.
So.
Right. So.
And
yeah, Hillsdale, New York.
Yeah.
So what's Fredericksburg?
Fredericksburg is one of the sites listed on the intermagnet.org. I don't know what.
It is, I believe it is managed by USGS, Geological Survey, US Geological Survey. So they supposed to provide like really absolute precise value of local magnetic field data.
So it's magnetic WWV then.
Yeah.
Is he saying it's close to where he is? Or?
No, he's not. It's just the closest.
Okay. So would that be Virginia or Ohio or Pennsylvania?
That's it. Fredericksburg.
Yeah, that one.
Oh, there we go. So it's Virginia.
Yeah, somewhere like somewhere in the middle of the Virginia, I think.
Unfortunately, the closest one to me is in either Boulder or I think Bayou St. Same
One in
there.
Denver. Yeah, that's the Boulder.
Baton Rouge.
Here's Baton Rouge.
Yeah, it's
Now
by
what
St.
about
Louis.
Just wait till we have all
Supermag?
ours online.
What? Have you checked
You'll be able to see
Supermag?
the map of the U.S.
Right.
I don't know if he knows about Supermag. He's looks like it may be a lot of the same sites. Well, there are. Are those active though?
So, okay, so red is available station, white is.
It's the same sites.
There's one in Kansas, Dave. Isn't there one that right there?
Yeah, but they're not available, I don't think.
Oh.
And there's truly almost nothing in Missouri.
What's the one in New Hampshire? That, I think.
Grafton?
Yeah, I was going to say we used to have one at Mike Trimpe's house in Grafton, but I don't think it's giving data now. I was just over there.
How do you get data out of it?
Yeah, and unfortunately, it's not a matter of getting it up and running because he's moving out of his house.
I mean, it looks like it's giving us. This is from 2001.
Yeah.
So
that's what it has data, but not current.
No.
That's
Yeah,
deceptive.
I mean, that's the thing. Supermag has big delay, so you cannot get up-to-date data. So that's why I was relying only on JNIJump data. Right now, there's no official data set available here.
Yeah, look, all of that's no data available, and that's
So
for
that's
January.
why we have to rely on other commercial magnetometer or JNIJump, which we have direct access to. So.
Yeah, so I actually was just talking to Mike. I was over at the house pulling some of our equipment out and such, and asked him if he knew where that magnetometer was. And he said, "I think I do, but I'd like to see if we could dig it up and relocate it, and get it active again."
One?
Yeah, the Grafton.
Well, why don't we? That's very
I know
good.
right
Wow.
where it is.
We have other topics, I suspect.
Yeah, we're actually getting kind of late, but I think we should go over to Scotty and keep talking about the clock modules and the RF module progress, because I know that was also under discussion.
Okay. Let me share my screen here, Nathaniel.
All right, you should be able to do that.
So if I share the screen with my picture on it and the screen is in my photo, is that like back in time? I can look back in time?
Yeah.
Well, this is kind of what, you can see this, right? The schematic?
Yep.
Let me get these off here. So this is kind of what John and I came up with for the first swag at the magnetometer. And what is in here, in this left half here, is all going to be designed by John. And but what I need is this connector right here, because once we nail that down, that's all that comes in and out of the data engine. So we have to be able to, we have to have a fixed pinout to do it. So at any rate, the idea is that see if I get to see, we're going to put a small FPGA on the board, which is what I don't know if you can see my cursor here. So the second box from the left. And this part's about, you can buy it for about $9 or $10 from DigiKey in quantity. So it'll be probably a $5 part maybe when I get done with it. It depends on what kind of deal I can get on it, but it'll be inexpensive. And we're pretty much using it as, it's got 130 IOs, so we're pretty much using it as a pass-through for everything. So make it easy, just connect everything up to the FPGA and then you can route things through it, except there's a few exceptions that you don't want to route through the FPGA for timing reasons, and we don't do that. But I guess the key things that we came up with were the parameter flash here. This is a serial flash memory that we're going to use to store the configuration and the various coefficients and things that you need for the GPSDO. so that the FPGA doesn't have to reload it every time you turn it on. And because this is also, the plan is to make this board available on a standalone daughter card as a instrument for people who want a GPS DO in their ham workshop, in their lab. So this will be a module that you'll plug on either to the data engine or to the carrier board that John will then subsequently design, which is in the future. And this is a dual frequency GPS, so we'll be able to do TEC measurements. And we talked briefly about that. It looks like to do TEC measurements, we have to export a bunch of data to a PC or maybe the single board computer and have it do the calculations there. We're not planning to do the calculations for TEC in the FPGA, and it's certainly not in this FPGA. That'll be in the future where that lands, where that piece lands. But we have basically what comes out of the GPS is a USB port to a PC, and this is used for configuring the GPS. There's also a data input port, which we aren't really sure what it's going to be used for because it's an input data port only, but he's going to put a connector on the board so that you could have access to it. And then the idea is that we have this UART and this I2C bus that are the two communications buses between the FPGA and the GPS. And he claims that you can put all the data on one of these ports, or you could split the streaming data put it onto one port and use the other port for command and control. So that's why we put both of them on here, especially since we have lots of extra pins. It makes sense to actually have the capability to have two separate interfaces just in case we need them. Then the time pulses, this is the 1 PPS, the raw 1 PPS coming from the GPS. And then I'm not sure what he's going to use these other 3 for. He says these are optional, so we put them on there. They'll be used for sending modification data from the GPS. I don't know what they're for, but these are not serial data lines. These 3 right here, these are actually signals that have timing information on them. And then just for good luck, a bunch of spares because we have the pins. Whatever extra I/O I have over here, I will hook it up to the FPGA or John will. And then
just a piece of information, the optional data port, when it's receive only, that's usually for something like differential correction data.
Okay. So how we would use that, I'm not sure what the answer is, but if it's there, then we'll want to make sure it's at least accessible so you can get to it.
Right.
Because if anything, this is going to be an experiment. There's nothing else. The USB blaster for programming the FPGA, that's pretty common. I put some sizes of chips down here. We're trying to get an idea for how big the board would be. We're trying to keep it in about a 1 by 2 inch form factor. And you can see how the GPS takes up about half the room. So we'll see how successful we are in keeping it small. Anyway, what happens here is that down here, this is a phase comparator, which we're basically taking the 122.88 megahertz clock and dividing it down to a 1 pulse per second. And then we're taking the 1 pulse per second out of the GPS, and we're doing a phase correlation and feeding the result back via a SPI port to the FPGA. And then so we can get an idea of how far off, or actually we can adjust our VCO frequency, our 122.88, to phase align the 2 1 pulses per second. This is what he can explain it a lot better than I can because I'm not really a time nut guy. I'm more of an FPGA type of guy. So I'm just trying to get over to these connections over here because this is what I need to put down on the data engine. So again, what's going to come out here is a pulse per second from the FPGA and a corrected pulse per second. He says these will basically be the same, only one will be closer to real 1 pulse per second than the other one will be, because we're going to adjust it based upon data we get from the GPS. Then a 10
Oh, right. That works with sawtooth correction from the GPS.
And then we have a comms channel, which is either two I2Cs or a SPI port. And then I'm going to put a couple extra pins on here, but not too many. I think just two extra. So we can have an extra I2C port if we need to do that between the two FPGAs, one on the data engine and one on the clock module.
Why would you need both the PPS and the corrected PPS?
That's a good question. What it amounts to is jitter. So the regular PPS is essentially raw coming out of the from the GPS, and then the corrected is it's called sawtooth correction that takes the jitter out of it. Now, why both of them get fed, I'm not quite sure.
He said this will be bouncing around at,
right.
Yeah.
4 nanoseconds either side or something.
So are there times where like the corrected PPS is not available and you like fall back to the regular PPS?
I don't know. That's a John question, but
okay.
He seemed to think it was important to have both of them there. So, and really, what's important, what's questionable, is the 10 megahertz. But these signals are coherent with the 10 megahertz. So this gives me an easier way to clock it.
Yeah, I'm concerned about the 10 megahertz coming straight out of the FPGA.
Why should that concern you?
Because it's got a lot of ground bounce on it. It's got jitter.
Yeah.
That needs to be reclocked to clean it up, but maybe he's doing that in the, maybe that's being done in this other, where it's being fed.
What, over here? This is not raw.
Or the other direction.
Over here.
Over there.
The data engine. It's going to have to be synchronized with the local clock there, so it's going to have to be cleaned up. The other thing that we can do is we can make it differential, which will help keep the noise off of it.
Yeah, but yeah, well, before you get it to a converter, you need to reclock it to clean it up.
What do you mean to a converter?
Well, before you put it into an A to D or D to A.
Oh, the 10 megahertz?
Yeah, or whatever is feeding the sample clock.
What do you mean by reclocking it?
Meaning you use you clock it by the highest frequency clock to clean it up.
Right. Right now, the 12288 oscillator drives 4 differential line drivers, and those are the clocks to the A to D.
Okay.
Right.
Yeah, these are the clocks to the actual receivers, receiver and transmitters. This has nothing. This is strictly has to do with the GPS function. In fact, we really don't even need the 10 megahertz function. I mean, what's important is the timing of these pulses.
Okay.
And likely, most of the data is going to come directly from this FPGA just being put onto the Ethernet in the Ethernet packet and shipped off. And
we do need time of day information in the data stream, so I presume that's where that's.
So we'll get a time. We'll have to generate a timestamp in the data engine FPGA.
Right.
This is the connector that goes to the data engine. Okay, so the data engine hangs off here, to the right.
Yeah, the data engine has to use that information to do the time stamping of the packets and the identification, so that we know precisely, we can compare data packets from different sites.
And the pulse per second is just the timing information for that particular stamp.
Yes.
Okay.
So then the idea is that we have DAC control, and this is where I think John's going to call you, Tom, and ask for some help on this. Since you did that DAC comparison or ADC comparison, I think, for SDRs, he's going to call on your expertise again to try and close this loop here on the clock module.
Last I talked to him, he indicated he thought that oscillator needed to be an ovenized oscillator.
Okay. Well, okay, so before we get too far,
maybe obsolete.
Okay, so this is actually only one of 3 clock modules that we're planning. This is the mid-grade one that basically generates 422.88 megahertz clocks for ADCs. The low-end one is basically everything you see on this page is gone. These wrap around to these. So the top 4 wrap right around, and they're going to be a 32nd inch wide trace because we're going to arrange the pins right next to each other. The idea being is that you plug in a dummy clock module, and then you get relatively low-grade clocks, but generated from the FPGA. And this is not going to be near as good as what you would get with this clock module, but it's a lot less expensive. So it's the beginner entry level, I don't need a GPSDO solution. And it uses just a dummy module that plugs in and has traces on it, no active components.
Mhm.
Then this would be the mid-grade part that would generate all of the same signals out on all 4 clocks. The higher end one would be to replace this with a synthesizer chip. And Silicon Labs makes a low noise, low jitter synthesizer chip that has separate outputs. So what you could do then is you could set each ADC channel to a different frequency if you wanted to do that. And this would be for more higher end systems. We may not even use that for the Max 10 system, but it's a possibility. We want to keep the clocks separate so that we can do that.
Mhm.
And then of course each RF module has 2 dedicated clocks coming back to the FPGA, so we can do source synchronous data from the ADCs back into the FPGA. So the RF boards receive a clock, one here for RF module 0, you can see right here, and one to RF module 1, and then this one actually goes back into the FPGA in case I want to clock my FPGA at some non-related frequency to 122.88. So I mean, we get the flexibility here to do all of these things. We may never end up doing them, but the paths are all there for us to experiment with. So the high-end synthesized module will be able to select different frequencies for all of these outputs.
Scotty, so the higher end module, that's going to have those 4 programmable clock outputs, and that'll be one of them that I could use for mine, right?
These 4, well, this goes to these 2 go to the RF module. This goes back to the FPGA. Actually, this is optionally going to go back to the FPGA. The reason this is drawn like this is because this part has 3 outputs. So until I end up finding a replacement part that has more outputs, we don't really need 2 identical clocks going back to the FPGA in the mid-grade sense. These would be identical, so you really don't need that. If this was a synthesizer, you might need 2 different frequencies going back to the FPGA for some reason. Because, for instance, on one of the modules, you might have a receiver and a transmitter, and you might clock them at different frequencies. So you might need to have you may need to generate different frequencies. So, and this has always been kind of a nuisance because FPGA clock inputs and clock outputs are different from standard I/O pins. So you've got to pick them in advance, and you got to wire them up to handle clocks. And of course, they're differential, so you have to route them properly, and you have to get the right impedance and all that. But more important than that, you have a limited number of them, so you have to hook them up to the right pins. And then of course the FPGA has 8 different banks that may run at different VCC/IO voltages, so you have to make sure you align those with the thing that you're driving. So, like in case you noticed, each one of these, this one and this one, operate on different VCC/IO voltages. This goes into banks 2 and 7 on the FPGA. This goes into banks 3 and 4. Well, 2 and 7 are committed to RF module 0, and 3 and 4 are committed to RF module 1. So whatever voltage I'm running RF module 0 at, which in the case of the one that Tom designed, it'll be 1.8 volts. This VCC/IO 27 will be 1.8 volts. And therefore the clock will be 1.8. So when I run it to the RF module, it's at 1.8 because we strapped everything to be 1.8 for that board. And that's settable on the data engine with the strap. We have a dedicated regulator which has 3 settable outputs by moving a strap. So you can pick 1.8, 2.5, or 3.3 IO standard for each of the RF modules individually. So that would mean that we could run Tom's 1.8 volt module, and maybe Jonathan's module is a 3.3 volt module. We could run that at 3.3 on the second RF module slot. Now, Jonathan, you asked what goes to the leaf module.
Yeah.
I haven't quite figured that out yet, so that's what's coming up next, because that's the last of the clock sources and destinations I've got. And the clock sources are getting kind of thin, so there may be some funky requirements, like you might have to use a 1.5 volt clock.
All right, that's fine.
And if that's okay, and normally I would say, well, if it's just an input clock, you can use a level translator on it without too much fuss. If it's something that is a source synchronous clock, you can't do that, because you can't, I mean, you can, I guess, but you affect the source synchronous path, the setup and hold times between the clock coming out and the data. So you really don't want it. The source synchronous path is meant to have all of the data lines in the clock line grouped together, and they feed this destination. So.
Well, in the case of reading samples from the ADD converter, would a source synchronous clock be necessary?
Well, perhaps not at the speed you're going to have to go at, because you're not going to be sampling at 122 megahertz, I believe. Are you
right. Yeah.
Because you'll be going at a much lower rate, which is easy. Once you get below about 30 megahertz, then you can even use just regular IOs on the FPGA for clocks. And because you get the setup and hold time is phenomenally long compared to 122 megahertz, where the whole cycle is only 8.3 nanoseconds.
Right.
Yeah, and secondly, the RF modules are using the double data rate interface. So they have to send a clock, and it's clocking data signals that are essentially at 245 megabits.
Yeah, it remains to be seen if we're going to be able to make it work, right, Tom?
Well, I hope the part should work. The question is, will the FPGA, can it recover double data rate? Since it's source synchronous, you're getting the clock that goes with the double data rate signals all together.
And we'll match the length of the data pins and the clocks. So.
Right. Well, and the part that we're using, you can program the clock delay separately from the data, so you can shift it back and forward by, parts of, I think up to a couple of nanoseconds if you need to compensate for delay variations.
Yeah, and the FPGA, you can do that also. You can, on the double data rate, you can move the clock around. The only problem is if the setup time plus the hold time is greater than the clock period, you're kind of SOL, because you can't satisfy both. So we'll see. That's.
Well, I assume that there's a double data rate input macro in the FPGA.
Yeah, there's actually double data rate hardware in the I/O blocks.
Okay. So that, yeah, if the FPGA is spec 245 or more, it should be okay.
So at any rate, there is the clock module, the first draft. So I'm supposed to mark this up and send it off to John. He's going to redline it and send it back to me.
Scotty, I think you might have mentioned this before, but refresh my memory. Does this GPS module have provision for an external powered antenna?
I believe it does.
The F8T does, I believe. The 9, I think, probably does, but I'm not sure. I think there's if it's not within the F9T, certainly it's easy enough to put it on the board.
So that would be desirable to put the bias T on the board so that you could.
Well, yeah, the F9T may have it in the package itself. I'm not sure. If it doesn't, then we'd put the bias T right on this board.
I do believe that the F9T at least has an option for antenna power input.
Okay. Yeah, that's something you would want to likely fuse if you're going to feed an antenna power pin to the F9T. You'd want the board to fuse it somehow.
And one of the other things we've done is up here, we've provided 12 volts. And this is really only limited by the connector, because this 12 volts is not really, it's nominally 12 volts. It's actually input power. So it doesn't come from a regulator. So it's only limited by the connectors and the power source you have. this is here to provide for an oven in the future if, because I guess ovens are pretty hungry when it comes to power. So
Yeah, when I talked with John a few months ago, and in order for him to achieve some of the pretty rigorous performance he was looking for, he thought he might need an ovenized oscillator.
Yeah, I think a lot of our applications would want one.
yeah,
And what it is it draws a lot of power when it's first heating up, and then the current draw drops.
because it's insulated, right? So it's supposed to be
Correct.
Okay.
Well, the GPS antenna power I was talking about is, I mean, some GPS devices, the antenna has a little preamp on it that is powered by the GPS module. That's what I'm talking about.
Yeah. So power for an active antenna.
Use that.
Yeah, most of that circuitry, that's very common. In fact, probably the most common type of antenna. And so the modules know that, and they're designed to help provide the power to those antennas.
Okay.
Yeah, the GPS module has that provision.
I'm taking one apart to see if I can tell right now.
Tell what?
I don't know if it's got a, if it's
Taking
got a
which
bias
apart,
to
the antenna or the GPS module?
the GPS, GPS ZF9T assembly.
Yeah. Oh, that definitely has a bias T in it. You
Yeah,
usually can disable it if you want, but 99% of the time we use it.
I believe that model specifically has options. You could use either a 3.3 or 5 volt antenna.
It does, because it's got pins called ant detect, ant off, and ant short. So it's got.
It's always detecting whether you actually have an antenna preamp at the other end.
Just to let everyone know, we are over time. It is now 10:18 p.m. So,
Well, I'm done, so I just wanted to share this with everyone.
Great.
I think it looks wonderful.
Okay, very good. Scotty, we'll hold till next week discussion on timing.
Okay, sounds good. Well, maybe think about this. John may drop you an email. But I got a lot to do this week anyway, so like it sounds like we're about ready to drop the hat on the magnetometers and go for it. If it's because it seems like they're working.
Well, sure looks encouraging.
It does.
Yeah, that's very encouraging.
So I got to get with the CAD guy and get the few changes made that we found in the review, and then get it going.
Yeah. I think Aiden Montari jumped in here too, and he wanted to talk about the code review thing, but I don't know that we're going to have time to do that this week, unless you just want to say like a word or two.
Yeah. No, that's all right. We can maybe talk on Thursday for those who are in the HamSci call. But yeah, I'm interested in putting together a sort of informal code review session. So if anybody is interested, I sent out an email with more details, and feel free to give me your thoughts. I haven't picked a day or time yet, so fill out the form I sent and let me know.
I think one of the things that's important to know about this is like a non-mandatory thing. This is for just, it's like a voluntary for people who want to do it, right?
Yeah, I'm not proposing that we institute a code review policy or anything. This is just, if you want to bring things to get others' opinions on, then you can do so and have a group of receptive people to do that. So this is completely informal and voluntary.
Yeah.
If y'all want to decide to have a code review policy or something like that, that's a whole nother discussion, but that's not what I was trying to start.
Yeah, no, I think that the informal approach and having a place where people can go, I think that's a fantastic idea. I think anything that's, going to be more formal, like Bill is saying, technically Alabama and Bill's team is in charge of the code, overall code for the project. So they kind of have final say on that. But I certainly encourage some sort of an informal place where people can come and get advice or ask for help or show things and the like. So yeah. Well, I think that sounds good. Is there anything else anyone wants to say before I cut the recording?
Good session and great data on the magnetometer. Thanks to Dave and everybody.
Thank you.
Yeah.
Good news on the magnetometers. That's
Making a lot of good progress. Yeah, absolutely.
Yeah,
Encouraging.
that's wonderful.
Yeah, this
Super.
is Jay, WB at SBI. Just a general question with regard to software. What language are you guys using? Is this being written in?
A variety of things. Um, an awful lot of Verilog, a bit of testing code in C perhaps, but probably primarily Python. I don't know. I can't speak for Bill.
Well, the software for the Tangerine, there's a main control module, and the FFT stuff that analyzes.
Lost you, Bill.
Yeah, your audio is gone.
How about now?
very weak.
Very weak audio. No joy.
There you are. What?
Well, I don't know.
Yeah, you're
There
back
you
now.
go. Now you're back.
Got a loose connection, I guess. The control module is in C, and the user interface is in Python.
Yeah, because, okay, my background was in automotive embedded C. And using the Motor Industry Software Reliability Association's MISRA standard, a lot of compilers have that standard baked into their tool set. And when you turn on that tool set in the compiler, it does a lot of this code checking for you, and will give you all kinds of data that says, this is bad, don't do this. Otherwise you could crash or have a runtime failure. It may compile and link, but it just may not run the way you think it's going to run. So if anyone's more interested in that, I can be more than willing to help out.
Does GCC support it?
Say again?
Does GCC support it?
That's what I was going to ask.
I don't know. The MISRA, the standard to buy the standard itself, it's a document, is 10 British pounds. And it's really easy to read. It's a real easy read, and it's just chock full of common sense things. So maybe somebody has incorporated into the compiler or not. Once you buy the document, it's like, okay, you own it, no big deal. And even if you don't have it baked into your tools, then you can still use it manually and say, oh yeah, here's a code review. We should not be doing this, or we should be doing this, and take it from there. I bought a copy for AMSAT, and they use it. And when I was part of the AMSAT Oscar 85 team software. And when we used it for our code reviews on 85, most of the time was like, oh, this is minor, no big deal, let's get it corrected. But there were a couple of instances when it's like, oops, if we had flown with that code, it would have bricked the satellite. It had the potential to turn Oscar 85 into a flying brick. So, and it's used religiously in the automotive industry. So I wanted to bring it to everybody's attention, and if you're interested, I'll be around. WB@SBI@ARRL.net. More than willing to help.
I take it that is to the automotive industry what ADA is to NASA.
I truly do not know that, but all I can say is that MISRA has gone way beyond automotive. It started in automotive, but lots of other industries have adopted it. Lots. It's used in aviation, medical. It's used all over the place.
Well,
So
could be useful to avoid data loss.
Yeah, it's got all
When we've
kinds
got
of,
these big networks of receivers distributed around,
yeah,
don't want them going down.
yeah, and a lot of it is really, really, really simple, common sense stuff. Like if you have an if statement, the body of the if statement, even if it's only one line, one command, will have opening and closing braces. Simple. And there are other things like thou shalt not do, a whole bunch of things thou shalt not do. And the reason being is not only you can't guarantee the result, you can't guarantee that the binary is going to do what you think it's going to do and what you want it to do. Some of that could just be engineer malfunction on the input side, or it could be that the compiler you're using really isn't doing what you think the compiler is doing or what you want it to do. So rather than guess or take a chance or say, well, the compiler, the ANSI standard says it should do this, don't take that chance. By following some of the very simple stuff in this document, in this standard, you are now overriding the compiler. You're not leaving any chance, any risk.
So this would be like, parentheses are a great example because you can force it to do it exactly the way you want it's defined and no room for interpretation, or you can rely on the compiler to do it in the order it's supposed to do it in, and maybe it will, or maybe it won't.
That's exactly.
In Verilog, I know one of the things it might do is require a begin and end statement for every group of commands. And I've seen so many people who will, if they say, well, if there's only one command in a loop, say, or in a case statement, you don't need to put a begin and end in. And it just adds a bunch of garbage. It makes it not look, well, then a guy comes along to modify your code, sticks another command in and doesn't realize that there's no begin and end. And now all of a sudden you just broke everything.
Yeah,
You exactly correct. Or you mentioned case statement. A case, you have case 1, case 2, case 3, and you
always have a default, right?
Always have a default, even if it's an empty default, even if there is nothing there.
Even if you define all of the possible states, right?
Yeah. Or if you have an if statement, you always have an else statement, even if the else statement is empty. It's open bracket, open curly brace, close curly brace. A lot of it is very, very simple stuff, but you'd be surprised at how many people don't do it. And there's other rules that are there are other rules. There's a lot of stuff in the document, but it's not rocket science. It's not. It's
I mean, it sounds like
really simple.
The document,
pardon me?
You could read through the document and pretty much adopt the coding style, and you would meet the criteria, right? I mean, it's.
Yeah, it's really simple, but it's like 100 and 120 rules or something. And the guys that wrote this, I know a couple of the guys that wrote this document. They are really, really very good embedded software engineers. They are extremely talented. They know their stuff. So this was not put together by just a bunch of hackers. This was some really, really serious, technically competent, technically qualified, guys that have 20 and 30 years experience doing C language and embedded software, from countries all over the world. It was an international effort. So anyway, I have a copy of the document. If you want to talk more about it in a later session, I'd be happy to put it up and let everybody see it, and we can talk about it in detail then and decide what you want to do about it. Back to net control.
Thank you very much. I think this will probably be something we continue to talk about. And as I have mentioned, we will kind of take the lead of Bill Engelke and UA Group as they are the official code people of this project. But I think it's definitely a very nice software, and I think it's certainly something I'm not familiar with. So I think it's good to have a discussion, and it does sound like it has quite a bit of value too.
Yeah, and all of you, I can pretty much guarantee that all of you are right now, when you go to your car, that many, if not all, of the electronic control units in your car use it.
I don't find the Misra web store where you're supposed to be able to buy this thing.
It's not, it's at the, you have to Google the Motor Industry Software Reliability Association, MISRA.
Yeah, I'm at misra.org.uk. Buy
Yeah.
online, but
Yeah,
none of it's clickable. The publications all seem to be downloadable under publications.
Oh, okay. I can't. That's where I got it from. So maybe there's a website problem.
It looks
What I want to know is if James Bond uses it in his cars.
I can neither confirm nor deny the presence or absence of nuclear weapons on this installation.
Yeah.
But I can tell you if he does, and if the people who wrote the code for his car did it in accordance to the MISRA standard, let's put it this way. You can write code that tells the dog to go lie down on the railroad tracks in front of the speeding train. MISRA will not prevent that, but MISRA will prevent bad coding and bad tools and bad compilers from preventing the dog, preventing your instructions to the dog to go lie down on the railroad tracks in front of the speeding train.
Yeah, you can. I'm sure that you can follow the standard and still write buggy software.
Oh yeah, definitely. It has nothing to do with if your software is going to work as intended. It has absolutely nothing to do with that. All it will help you do is to write very good buggy software.
Well, I see what Dave is dealing with here, and that there's a whole long list of publications not clear
I
where
think
you start.
I think I found where you make the purchase.
I see the purchase. I also see a long list of PDFs that it's not clear where you start on it.
You want the C, MISRA C for the, well, in automotive, we use the C language. So it's MISRA C, it's a PDF.
I think it's the
MISRA
one.
C, they're all a bunch of addendums and everything.
No, I think I see it. I think if you're on this page here.
I hadn't found that.
I put this link in the chat. And then if
Okay.
you go down to here, I think this is the current one.
Yeah, that looks about right.
Now this is 45 pounds. So that's
okay.
That's the hard copy.
Okay.
I think that
here's the PDF. Okay,
Yeah,
it's
15 British
15
pounds.
pounds.
Yeah.
So yeah, MISRA C 2012 guidelines for use of the C language in critical systems. That looks like the one that you're probably talking about.
Yeah.
And then you can put, I guess, a number 1 in here. And please enter
I would put Nathaniel or whoever chooses to buy this. You might want to put like University of Scranton in there.
Okay.
That way you can pass it around to the entire school.
Yeah. And then you go to the bottom, you can hit add to basket or review basket. And then you can purchase it.
Yeah. Do you mind if I get in word here?
Sure.
Yeah. So so thanks for bringing that up, Jay. I just want to clarify that like this is all interesting and useful discussion, but it's a slightly different topic than what I'm proposing. Like this might be something that we talk about during the sessions that I'm proposing. but just to clarify for everybody else that, like, I'm not proposing I wasn't proposing any kind of standard to adhere to. I was just proposing a discussion section. So we should definitely we can talk about these things. I just wanted to clarify that I'm not proposing a session in which coming to the session means you'll have to adhere to some standard or something like that. So I just wanted to clarify that so people understood what I was talking about.
No problem. Just by way of my background, I spent 28 years in embedded software in the automotive industry. So, we did this stuff all the time. For us, this was routine. You write it, you test it, you think you got it right. And okay, when's the code review meeting? And oh, by the way, you wrote this many lines of code. That means you have to give, this many days notice to the people so that they can review it. And you got to do this, you got to do that, get ready for the meeting. And if you came to the meeting and there were still outstanding issues, basically you wanted to have all your issues resolved before you came to the meeting. The meeting should just be a formality.
Thank you
So
all.
anyway, that's just where I'm
got to drop off. Thanks.
Okay. Thanks,
you.
guys.
Yeah, I gotta go too. I got an early day tomorrow, so.
Yeah.
70.
All right, everyone.
Thank you to everybody.
Thank you. 7-3.
All right.
7-3. Good night, everybody. Stay
Good
safe.
night.
7-3. Bye-bye.
Hey, Nathaniel, I'll send you an email tomorrow.